When astronomers describe where our Sun is in the universe, it is normally put as being in one of the spiral arms of the Milky Way. However, the Milky Way is itself part of what's known as the local group, basically a collection of galaxies being attracted towards each other by the mass and gravity of all the other stars in the local group. The local group contains three larger galaxies, which are in order the Andromeda Galaxy, the Milky Way, and the Triangulum Galaxy. There may also be as many as 50 smaller dwarf galaxies within the local group. It then becomes difficult to be really precise with all the stars moving relative to each other and working out who is close to who and what actually defines the limit of one dwarf galaxy and one galaxy is close to another. Are they actually one galaxy or two? This clustering of galaxies continues as we increase the scale. The local group is itself part of the Virgo Supercluster, maybe 110 million light years across, which compares to the Milky Way being 105,000 light years across. Inside the Virgo Supercluster may be anywhere from 1,300 to 2,000 galaxies, and potentially the Virgo Supercluster might be part of an even larger supercluster, stretching like a thick ribbon of stars across space. The issue with galaxies and superclusters is since the galaxies within the superclusters have their own momentum, the galaxies within the supercluster might actually be gravitationally bound to each other and may occasionally be cast off from the supercluster or just break up and disperse over space. And while individual superclusters are mind-bogglingly huge, it's possible that there may be as many as 10 million superclusters in our observable universe. That still leaves an awful lot of empty space in our universe. Brings me to the next thought about superclusters and space. In our solar system, when we leave our planet, the space between our planets we regard as a vacuum. But in that vacuum, there's still some hydrogen and a few other occasional atoms and particles moving around our solar system. The Voyager 1 probe is now just leaving our solar system, entering it into what's known as interstellar space, where the chances of encountering matter become even more remote than actually inside our solar system. However, that interstellar space is still part of the Milky Way, which is in turn part of a Virgo supercluster. So it's part of a huge mass of stars and other objects sucking in matter by their gravitational pull. So even interstellar space isn't a perfect vacuum. However, in approximately 90% of our universe, which isn't actually part of a supercluster and is presumably just empty space, makes you wonder how complete is the vacuum between the superclusters, and what would that complete vacuum create? Any particular special effects that we've yet actually to encounter in the vacuums in our solar system? Could potentially the speed of light be even greater than we've imagined it when it travels totally unobstructed through a complete vacuum? Could the vacuum would also not just lack any matter, but also lack any energy? Again, might create some exotic effects we're currently unaware of. The question then would be, how do you actually measure the effects of nothingness from a distance?